Hello students, once again you're welcome to Waidsum University, and today we're looking at chapter 9, the routing protocols. And under the routing protocol, we're looking at chapter 9, section 2, which is static routing protocol. Okay, static routing protocol. Without much ado, let's begin. Okay, before we go into the details about static routing protocol, like we said, routing protocols, they are divided into two. We say they are divided into two. We have the static routing protocol and we have the dynamic routing protocol, right? So today's section will be looking at static routing protocol, which is the first part of routing protocols, the static routing protocol. Now, when we say static routing protocol, it's just a form of routing that occurs when a router uses a manually configured routing entries into the routing table. So when a router manually, okay, underline the word manually uses the routing entries that have been entered into the routing tables. The routing entries that have been entered into the routing tables, usually they are the IP address of the destination, the destination device, the IP address of the subnet mask, the IP address of the nest hop, all of this, they constitute or contribute to what we call the routing entries in the routing table. So when we say static routing protocol, we refer to a form of routing that occurs when a router uses manually configured routing entries rather than the information from dynamic routing traffic. Instead of getting the information dynamically from the routing traffic, but the router will choose to use manually enter the routing entries into the routing table. Okay, so we say in many cases the static routes are manually configured by what? By who? By the network administrator. They are manually configured by the network administrator. Okay, so they are manually configured by the network administrator by adding the entries like the IP address. When we talk about the entries, we're talking about the IP addresses by adding the entries such as the IP addresses, okay, into the routing table, Is that okay? Okay, in some cases this may not always be the case, but most of the time this is what it is. Okay, the network administrator will enter details into the routing table. Is that okay? So a good example of static routes are created in global configuration mode. So when we are creating static route, we create them in global configuration mode. Is that okay? So we can simply say static routes are created in global configuration mode, right? They created in global configuration mode and requires the destination IP address, what you call the destination entries or the destination prefixes, okay, and a way to get there. How this data packet from the host computer will get to the destination computers, right? So let's say, for example, if you have a router with a serial interface 1/1 interface with an IP address of, let's say, 192.168.1.5, maybe from 1 to 30, you have 30 computers. So starting from 1, okay, or from 5 to 30, it must have a point-to-point link with another router, maybe with a serial 2/2 with an IP address of same 192.168.1.6, 6 to 30 now. The previous one was 5 to 30, from computer 5 to 30. This one is from 6 to 30. So when there's a point-to-point link, then the static route will be manually configured, can be manually configured to pass through the next hop in order to take the data from the host computer to the destination computer. In order to take the data from the host computer to the destination computer. Here, for example, here is a local area network. Here is a local area network. And this local area network is has this computers, computer A1, computer A2. This A2 is acting as a server, computer A1 is one of the host computer, and they connected to a switch. This switch is linked with a default gateway to this router. Okay, this default gateway has its own entries, okay, which is 10.10.20.0, one of the IP address of the subnet of the default gateway from the LAN A to this router. And then from LAN B, let's see if we can take a highlighter. Okay, this is LAN A, right? This is LAN A. This is LAN A. Now this LAN A has a default gateway here, from here to the router, which is 10.10.20.0. Okay, so this is the default gateway upon which any data packet here is propagated or sent to this router with fast Ethernet 0/0 interface. Okay, so through this, the data packet is propagated to this router. So from this router, we must create a static route where this data packet can be sent to router B. Okay, you know it can go through this interface fast Ethernet 0/1, which is 10.10. The default gateway will be 10.10.200.0, and also has another interface through which this data packet can be propagated or can be sent or transmitted, which is 10. Or routed. I think the most word here will be routed 10.10.100.0 net. Okay, these are the subnets or the IP addresses of the default gateways. So this can come to router C, from router C then back to router B. So there are two ways through which any data packet from here, from LAN A, can be sent to router B, either through this shortest path, a link, a point-to-point link established between the router A and router B, and through an IP address, a default gateway of 10.10.200.0, which is called the static route, because we have to establish this static route such that the data packet from LAN A can be sent to router B in LAN, which has something to do with LAN B. And then on getting here, because the MAC address of the destination device has been entered into the data entry or the routing table, then the data will be forwarded through this fast Ethernet 0/0 to LAN B, and from there to the destination computer where it's meant to be. So we're going to explain all of this. This is a sample of a campus network. Okay, this is another LAN B. This is another LAN B. This is LAN B, which is and here we have the a point-to-point static route established here. Okay, so you can see. So if we communicate from here, we're sending a data packet from this computer A. This data packet, you know, we've entered the destination. We're going to explain that the destination MAC address and the host MAC address. Okay, so it's able to be propagated, transmitted, sent through this default gateway 10.10.20.0 to this router. On getting to this router, the router will establish manually a route, a static route, upon which this data packet can be routed to router B from router A. So when it gets here, then because the destination MAC address is already established, because the destination IP address is already established, and then you see that this data will be sent through this link to this LAN B and to the designated computers. So but if it's to another LAN, then the journey, for example, if it's to LAN C, is going to use this default gateway fast Ethernet 0/1, not 0/0. It will use this. If it's going to LAN C, then it will be on this interface. Okay, so if it's going to LAN D, it means you have to also enter into the routing table the default gateway from router B to router C manually, from router B to router C, which we read 10.10.150.0, which means if the data packet gets to this router, it will not be forwarded through this default gateway to LAN B. Rather, it will also still statically move from router B to router C, where the data packet will be routed again to router C. Now, on getting to router C, because the MAC address of the computers in LAN D has already been entered in from the beginning, then the data will be forwarded to LAN D and then to the computer, the designated computer that is supposed to receive through the default gateway 10.10.5.0, using this default gateway 10.10.5.0 to broadcast this data to the computer designate. Okay, so but this we're going to explain in a more detail when we get to other sections. Now, to begin properly, we have to look at the observations in this place. Now, what are the observations that are very predominant in this lessons or in this chapter or sub-chapter? One of it is that we need a way to route data packets over the network. So that's the first observation, that we need to find a way to route data packets over the network. Remember that data packets in one computer in a network wants to be routed to another local area network that is different from local area network A. So we need to find a way to send these data packets to other MAC addresses in different local area network, invariably using different router. Using one router to propagate or to route the data packets to another router where the designate or the destination computer or destination MAC address is located. So that's the first observation. Okay, our second observation will be, is how do routers communicate and exchange routes? That's our second observation. How do they communicate and exchange a route? That's the second observation. The third observation is, how do we specify the next hop? Okay, so if you get these three concepts clear, then we'll be able to understand the concept of this static route, or what we're about to learn. That the first one, we need to find a way to route data packets over network. That's the first thing we need to know. The second thing is how do routers communicate or exchange routes? How do they communicate? The router themselves, they have to communicate with protocols, right? Called the routing protocols. In this case, or in this section, we say we're looking at the static route as means of communication between routers. So the third one is how do we specify the next hop, where the next direction where they have to go through. Okay, just a minute, it's our system is lagging a bit. So okay, so that leads us or brings us to understanding the type of protocol that helps to that router use to communicate with one another. That leads us to the kind of protocols that router use to communicate with one another. You know, we say the routing protocols are divided into two previously in section 1. We say they are divided into two. The first one is the static routing protocol, which is the one we're looking at in this section. The second one is the dynamic routing protocol. Okay, but we say dynamic routing protocol, we look at section 3, chapter 9, section 3, the next section. We're going to look at dynamic routing protocol. We said dynamic routing protocol, they're divided into two types. We said the distant vector routing protocol and the link state routing protocol. The distant vector routing protocol includes the routing Ethernet protocol, which is the RIP and RIP version 2. And then the dynamic one, we have the interior gateway routing protocol, open shortest path first routing protocol, enhanced interior gateway routing protocol. So we're also going to treat this one in subsections as we move further. Okay, so now the big objective of this section that we are dealing with, the static routing protocol, is for us to have a good understanding on how data packets are routed in a network using static routing protocol. That's the big objective. First of all, how data packets are routed in a network using static routing protocol. That's the first big objective of today's lesson. So we should know how these data packets are routed. They're sent from one router to another router. The second objective for today's lesson is which methods or which procedure or which techniques do we employ in configuring the static route. So first and foremost is to know how data are transmitted or routed using the static route. The second concept to understand or take home with from here is that we need to understand how to configure the static route that data packets can be forwarded with. Okay, so the method, the configurations of the static route methodology we need to also know. Now, like we said earlier, static route we say is a data traffic route that has been manually configured into either a routers or computers routing table. Okay, a data traffic route that has been manually configured either into a router or computer's routing table. Now, the routing table is just simply a list of IP addresses where the data traffic can be forwarded. Okay, list of ID. So when we say routing table, we're simply saying the list of IP addresses where we can forward the data packets. Now, let's take a look at PC static route first. A static route is specified in a PC's computer in terms of a computer's default gateway. So usually we use the default gateway. The first time 0/0, the first one we saw, which was 10.10.20.0. So a default gateway is used by a PC to send data to a router. Okay, and the router sometimes uses static route when displaying where the network data traffic is to be forwarded. They also use static route when they are displaying where they want to forward the data traffic or data packets. So let's take a look at an example of a static route for a computer. Now let's take a look at an example of a static route for a computer. Now configuring a default gateway. Okay, this for configuring a default gateway. Now this is a section of configuration section, the Internet Protocol version 4, TCP IP version 4 version 4. So here one for PC and the other one for the MAC address, maybe probably destination MAC address, because even this PC has a MAC address. Maybe this is the source PC and this is the destination PC. Let's take a look at this. So here you enter the default gateway IP address from the local area network to the router 10.10.20.1, meaning it's coming from computer 1 in this default gateway of 10.10.20.0. So it's coming from computer 1 in this 10.10.20.0. Okay, so it's coming from computer 1, so which means it's on the default gateway concept, and the subnet mask is always usually 255.255.255.0. Okay, now the default gateway, like we said, where it's going to follow to the router from the LAN A to router A is 10.10.20.250. This is the default gateway that we've set between the local area network A to router A. Is going to follow this default gateway 10.10.20.250. And then here, before you click OK, meaning you set the PC, your PC, you are saying this PC, the IP address of this PC is 10.10.20.1. So this PC is using this subnet mask, will flow through this or route the data packet through this default gateway to the router. That's what you've done here. Then on the second part, on the network part, here you can see the TCP. Okay, we click on the TCP IP. That's what we're entering. You see, configure IP version 4 manual. So we are doing static routing because once we enter data manually or enters data entries, that's the IP address. Once we enter them manually, it means it's a static route. If it's dynamic, to take it from it, it will be dynamic routing, because it means it will pick the data entries by the traffic dynamically or by itself based on the availability. But in this case, we are choosing manually the destination or where we want it to go, or where it's coming from, and where we want it to go. So we say, look at the IP address. We say 10.10.20.1, meaning it's coming from this 10.10.20.1. Okay, we've entered the source IP address. The subnet mask is 255.255.255.0, and the router gateway is 10.10.20.250, which are still same information that we are entering here. Okay, so after that we apply and then we click. So this is the MAC address, this is the PC, this is the MAC address of the PC, okay, of the source. This is for the source, okay, where everything is coming from. This is from the source. Now let's take a look at Now, we want to examine the PC's routing table. Let's take a look at the routing table. The default gateway, the most common static route used by the PC. Okay, the most common static route that is used by the PC is usually the default gateway. We'll show them in diagram in our figure, in our diagram. Okay, so then we also say we specify in the TCP IP setup for the PC. The computer is lagging on, maybe just like few seconds in order for it to come on, so we can move to the next one. Okay, so we want to look at the PC's routing table. Here in the routing table, we're going to see the IP address that we've talked about, like the 10.10.20.0 for the default gateway, or the default gateway specifically will be 10.10.20.250, and then we have the IP address of the 10.10.20.1 of that's the PC, and then we have the subnet mask. We have the 255.255.255.0, which is the subnet mask for the source PC. Okay, now once that is established, once we have established this, the next is to see the net start or the arrow command. The net start arrow command will show the route. Once you do route print, it will show you everything that you've entered. Okay, it will show you every detail. It will show you all the details that we have entered into this the system. For example, you see the network destination, you have the net mask, which is subnet mask, you have the gateway IP address, you have the interface. The interface, that's the computers or the system where these things are coming from. Okay, so you take a look at, because this is a display, the arrow command, the route print, it shows you the default route that is specified in the routing table. The routing table, you can see here the network destination, the network address is 0.0.0.0, and the network mask is also 0.0.0.0, and then the gateway address is 10.10.20.250. I will show all of this. Okay, then the interface 10.10.20.1, the interface, that's from the computer where it's coming from. So after that, we'll see also a feedback system, a loop back. The destination of 10.10.20.0 is returned to the computer's network interface card at IP address 10.10.20.1. Okay, so 20.0 is coming back to 20.0, which is the real computer, the computer itself. Okay, the computer's IP address is 10.10.20.1. So this is the, excuse me for a minute. Okay, 10.10.20.1. So the IP address of the computer that is the data packet that is returned to the computer is 10.10.20.1. The gateway for the network destination of 10.10.20.1 is 127.0.0.1. The gateway for the return. You know, every data packet, maybe you say a data packet, you can get a return, like the computer that you sent to also forward the reply to you that maybe has received it. So this is the gateway for the recipient. If you look at the subnet mask now for receive is 225.225.225.225. Sorry, 255.255.255.255. So this now if you look at the network address, this is the network address, meaning this is the computer that is receiving now, and this is the subnet mask, and this is the default gateway upon which the data will be sent back to you. Okay, so it's like a loop system. So let's quickly take a look at the part that I want us to see. This is LAN A, the local area network, LAN A. Okay, what about setting static route for router in a small campus network? Let's take a look at that. The first thing you do when you set a static route for a router in a small campus network is that you look how data packets travel from LAN A, and this is LAN A. We already said that this is LAN A, local area network. A. How data packet travels from LAN A to another 3 router campuses. So we have 3 routers here: router A, router B, router C. So a data packet from LAN A can be forwarded to router A or router B or router C. So any of these 3 can receive, okay? But specifically, we're going to use router A and router B as a case study. So how is information sent from a host computer in LAN A? Let's say this computer is a host computer from LAN A. How is information sent from this LAN A, which is 10, the IP address is 10.10.20.0, 10.10.20.0 subnets, to a host computer in LAN B, So whatever data packet is being forwarded through here or routed through here, it comes to router B and then comes to LAN B if the data packet is meant for route B, for LAN B. So how does that take place? And you have to also enter the subnet mask or the default gateway for router B for LAN B also, which is 10.10.10.0, 10.10.10.0. Now, the data packet must travel from LAN A to router A first. So from this LAN A, the data packet has to travel from here, LAN A, to router A. From LAN A to router A. That's the first thing that will have to happen through the what we call the default gateway, E0. E0 means fast Ethernet 0. Okay, interface. This interface is called E0 or FA0/0. Okay, through this default gateway. So data packet from LAN A can be sent to router A through this default gateway 10.10.20.0. Okay. Now from router A, it will have to be sent to router B via a 10.10 via where? From router A to router B, this data packet has to move from 10.10.200.0. Okay, this interface, a point-to-point link. Okay, from this router statically. Okay, so the data packet has to be routed to router B. Okay, so which is through via a 10.10.200.0 subnet, and then to LAN B. You know, when it gets to router B, we forward it to LAN B because the MAC address is already there. So the router already know that it's going to LAN B, local area network B. So it will forward the data packet through this fast Ethernet 0/0 or E0 to this LAN B. Now this requires a physical communication link. It has to be established between the routers and a routing protocol defined for routers A and router B before the data packet can be exchanged. So a physical communication will have to be established between router A and router B. Okay, this one is what we call the static routing protocol, which you're going to configure in, and we're going to talk about how static routing protocol can be established. We're going to talk about that. And once that is established, then this router can pass the data packet to router A can pass the data packet to router B, and then router B can now then forward it to LAN B, and then the designated computer will receive such based on its own IP address, and the switch based on the switch IP address, and then to the computer MAC address. Okay. Now here is an example. We're looking at simplifying 2 routers from the 3 router configuration. From these three routers, we're taking this router A and router B and LAN A and LAN B to simplify it and make it easier. So we're just using LAN A, one computer from LAN A. We take a computer from LAN A, okay, to router A, and then to router B, and then to. So here, what happens? The static route in the campus network is what we want to see how it's being established. Now, a simplified network can be used to demonstrate what is required to develop static route in a multiple router network. Now, take a look at this. 2 routers from the campus network we've chosen, right? We've chosen to illustrate what we were trying to explain. Now, these 2 routers, router A and router B, connects to LAN A and LAN B. See, this router A is connected to LAN A. Okay, router B is connected to LAN B. Router B connected to LAN B. So here you can see we have 3 IP address, 3 IP subnets. we have the 10.10.20.0 between this LAN A and router A, and then between router A and router B we have this IP subnet 10.10.200.0, and then between router B and LAN B we have 10.10.10.0. okay, so once that is established, let's see what is there. The data packet passed through a subnet, which we simply represented as net. You look at all of them, we represented them as net. The data packet passed through 3 subnets, which is simply net. When traveling from local area network A, when moving from here, local area network A, when it's moving from local area network A to local area network B, to local area network B, to local area network B. So it has 3 nets or subnets IP when it's moving from. The first one is 10.10.20.0, which is this one. This is the first subnet IP. Okay, the IP subnet. This is the first one. So from LAN A to router A, we got 10.10.20.0. Then from router A to router B, it's 10.10.200.0. And then from router B to LAN B, we get on that 10.10.10.0. So these are the 3 IP subnets that are available when that has to be established, or whose routing protocol has to be created in order for data packet in LAN A to be forwarded to a computer in LAN B. Now, in this network, there are only 2 routers as we illustrated. That's router A is directly connected to router B, as you can see, with a physical communication link between router A and router B. What this means is that the only route between the routers between this router A, the only route between this router A and router B is via this subnet, IP subnet 10.10.200.0, because we've simplified it. You know, it's no more 3 router. When we had 3 routers, then we have to create another route, right? There was a 3rd route. When we had 3 routers, there was another route. Okay, so, and this is the only, since this is the only connection between router A and B, this is the only way we can send data packet. So we have to create the static routing protocol through this channel. Now the static route information will be entered from the router's config terminal prompt. When we want to configure the static route, we go to the router config terminal prompt, right, which we have talked about in our previous learning about router. Okay, router config using the IP route command. You have to put the IP route so that the data packet will know where to route to. This command is exactly written this way. So in your router config terminal prompt, you have to write router, but you must put which router. If it's from router A, you have to say router A config hashtag IP route destination. Then you put the destination IP address, you put the subnet mask, you put the next hop. Now, where is the destination IP address? The destination IP address is 10.10.10.0, because this, you know, the data packet is coming from here and it's going to where? It's going to a computer B in LAN B of router B. So the destination IP address, this one will be, once you configure router A, you say router A config hashtag IP route. After you put hashtag IP route in your config prop terminal, the next thing to enter is your destination IP address. Your destination IP address is this one, 10.10.10.0, right? This is your destination IP address, 10.10.10.0. Then after that, you put your subnet mask, 255.255.255.0. You enter that subnet mask, and then you, after that, you enter your next hop. The next hop is the link, the physical link, the static route between router A and router B. So you enter your 10.10.200.0 here. So once you type this in your command interface, the router configure terminal. Once you type this in the router configure terminal, then you'll be able to create a static route between a data packet here to a data packet in another local area network. Now the destination is the network's destination IP address, which we've mentioned. Okay, the IP address. The subnet mask is what has been defined for the subnets that we have itemized, I have mentioned already, right? And the next hop is the IP address of the next router in the link. So from this router A, which one is the next router that the data packet will be forwarded to? So which is this one? So this is the next hop. This is what you write for the next hop. Now let's take a look at an example. So you say router A, you must, because it's coming from router A. Whatever you are sending is coming from router A. It's going to pass through router A. So you say router A. You cannot just say router. You must have a designated names for different routers, because after you've configured your routers, you must name your routers. Router A. If you want to use 1, 2, 3, 4, 5, say router 1, router 2. It's okay. You know what to call your routers when you're configuring routers. So now we've configured the routers. We already know them by names. This is router A. So when you want to configure the static routing protocol, you type in the command interface. You say router A config hashtag IP route. After you put hashtag IP route, you follow with the destination. This is the destination IP address. This is the destination IP address. You follow it up with destination IP address, which is this, because the data packet that is coming from here, the data packet that is coming from this place, is going to through this IP address to this local area network. So you have to enter the destination MAC address. Okay, then you put the subnet mask 255.255.255.0. You have to enter your subnet mask. After your IP address, you put the subnet mask to enable this to go. Then after that, you put your next hop address, which is where is the route from router A to where, to which router, in case there are many routers on the network. So it's through this one, which is 10.10.200.0. So you enter this your next hop, meaning you tell it the data packet from here to go to router A. That's why you say router A config IP route. Okay, router A config hashtag IP route. So once you do this, you're telling any data packet here, first of all, to move to router A. When it gets to router A, you're telling it that it should go to this destination, which is this one, this place, which is the whole of this place, that it should go to this destination. Now, when you say it should go here, you have to put the subnet mask to enable it to go. It's like a carrier. So you have to put the subnet mask. Then after that, the next hop. Next hop means which channel is it going to follow. Okay, you enter the static routing protocol by putting the channel, the next hop, through which place it will link to this side. You have to enter which. So manually entering this is called static routing protocol. You create a static routing protocol because you are manually entering this, okay, into the routing table. So this is what it is. The next hop address is the IP address of the Ethernet 2 port on router B. Okay, this one, Ethernet 2. The next hop. This is the next hop address. We've described that, right? Now the router knows how to deliver the data packet, because why? You say that it should go to router A from here. Router A, that it should follow this route, the next hop, to router B. And you've also said that router B should deliver it to LAN B. And LAN B, the MAC address is already there for which computer is going to go in route B, in LAN B. Okay? So this is what we have for this section, an example to illustrate how this thing works. Okay, now each static route can use a different subnet mask. Okay, each static route can use a different subnet mask. It could be from, the subnet mask is 255.255.255.0. So you can start from 255.255.255.0, 255.255.255.1, 255.255 up to 255.255.255.254. Okay. till you exhaust it to 254. Then we start again. Is that okay? So that's that for that. Now let's look at the show IP route. Now after you config, you want to see it, so you type the command show IP route. When you type the command, if you want to verify what you have done to see whether it's done well or it's proper, you say the routing address entry to the routing table. You can be verified anytime by entering the command show IP route. Show IP route from the router configuration. Okay, now let's take a look at an example. You say router A hashtag. You know, you must always use hashtag to put it in the privilege mode. Okay, so you say router A hashtag show IP route. When you do this, it will display everything that you have configured. It will show you everything, the type of route that are available. This for this enhanced interior gateway routing protocol. SE is exterior enhanced interior gateway routing protocol external. Okay, and then all the things that are there will be displayed. Okay, let's not begin to go to everything in the routing system configuration will be displayed. The gateway of last resort is not set yet, so most time we always set the gateway of last resort, because there are times where we have data packets whose destination address are not known. They're not known. So once we set what we call the gateway of last resort, those data packets will be forwarded to the next router. Okay, till the router is able to establish which local area network has that data packet. Okay, so you see here 10.0.0.0/24 is subnetted to subnet, and so on and so forth. Everything that is here is what you have done. Is what you have. What about the data traffic flow from the 10.10.10.0 of LAN B to 10.10.20? You know, we've already described the data traffic from router A or from LAN A through router A to B. Now what about going back from B, like a reply message from B to A? What about from B now to A? Then once you are going again from here, after this LAN local area network has received, he wants to communicate to A, then it's still almost the same process. Okay, the data packet passed through the 3 subnet as usual. That's this subnet, 10.10.10.0, this subnet, 10.10.200, this route between two router, 10.10.200.0, then this subnet 10.10.20.0 till he finds this computer which hosts which is not the destination in this case, Okay, so it's going to pass you through traveling from LAN B to LAN A. So if you're going back, if this computer has received, it's also sending the another data packet to LAN A, then it's the same process the way we came. Now the IP address is of LAN B will be stated first. This one, 10.10.10.0, then 10.10.200, which is now this one, .0, then 10.10.20.0, which is this one. So everything is going to go the same way we came. Okay, so we don't have to worry about that. Now it's just for you to configure it as well. That's it. So in that case, we want to do the configuration. What do you do? What do you do if you want to do the configuration? You're not going to say router A now. You go to, because it's coming from router B now. Router B is the journey, where the journey is coming from. So do not enter here by saying router A. You say router B, because everything is going from here all to this side. It's going this way. Everything is going this way now. So since it's going this way, I put an arrow to show that it's coming from this side going this way. Since it's going this way, you have to say router B config hashtag IP route, router B config hashtag IP route. There you put your destination. Now the destination is where? The destination IP address is 10.10.20.0. Okay, that's what you enter, this one. That's what you now enter. Not this one, 10.10.20, 10.10.10.0. It's no more the destination. The data is now going from here all the way to this side. So you're going to enter 10.10.20.0 as your destination this time with the same subnet mask 255.255.255.0, and then the next hop is also still going to follow this this channel as your next hop. So you have to enter 10.10.200.1.1, no more .0, because .0 was the fast Ethernet with which it came. Now going back, it has to be .1. Okay, but it's the same displays, but another, meaning you are going back 10.10.200.1. Okay, this is the only difference what you experience here, what you type, and then the following information enter into the router. The information enter into the router is the following. Look at it: the destination subnet, the destination, which is this one, 10.10.20.0, because it's now the destination. This one is now the destination. The subnet, which we already know, 255.255.255.0, and then we have the next hop. The next hop is still the same 10.10.200, but not .0 this time, is .1, because it's like a reply. Okay, so it's like a reply .1. Okay, a reply to the previous one. Is that okay? So we go to the next one. There we also have a command which is show IP route. Show IP route. So the same way for what we did before for show IP route, here you show router B hashtag show IP route. So it will display all of this one. This is the command you put in your router config terminal. Okay, so you say router B hashtag show IP route. When you do that, it will display all of this. Now you see the gateway of the last resort is not set still on this. So you see 10.10.0.0/24 is subnetted. We have to subnet, and here we have the destination to be 10.10.20.0 on the interface 1/0 interface via means the next hop where it followed 10.10.200.1. Now is .1, like I have already explained. Then the 10.10.200.0 is directly connected fast Ethernet 0/0, meaning this is how it came, and then he's going back with this one. It's going back with this. So let's take a look at what we have. Well, the example we illustrated, we took this router A and router B and LAN A and LAN B to illustrate what we were describing just now. Now, what about using static route in the 3-router campus network? In the case, or when we decide to use a static route, configure a static route in 3-router network, what will it look like? Again, you're going to do the same thing. A static route must be entered into the router's A's routing table, telling the router how to forward the data packet to 10.10.10.0. You have to enter it and tell the router how to forward this to this 10.10.10.0. So you're going to specify 2 routes. Now, the next hop will be 10.10.200.0 and 10.10.100.0, because the router can choose, router A can choose to forward it from here to here straight away to this LAN, or it can choose to forward it from A first to C and then to B. Okay, so once again, a static route has to be entered into the routing table, like we said, of router A into the routing table, telling the router how to forward the data packet of 10.10.10.0. However, in this example, there are 2 possible choices. I already mentioned that. For a data packet to travel to 10.10.10.0, right, net from router A, there are 2 possible routes, and I've already mentioned the 2 routes. I said the first route is this one, with which a router A can forward to router B. The second route is this one. Okay, we've mentioned that already. Now let's take a look at configuring static routes. Now these are some configuration terminology that you need to type in the configuration interface. Router, you must put the router router A or router B, whatever router you're configuring. So for general illustration, we just write router. But when you're doing and when you're using the interface, you have to put the router's name. Router A config hashtag IP route destination. You put IP route. You put the destination. You put the subnet mask. Then you put the next hop. So this is the command for configuring the static routing protocol. This is the general command for configuring the static routing protocol. So anytime we want to configure static routing protocol, we just go to the configuration mode, the global configuration mode terminal, and then we write router A. If it's we are sending from A to B, we say router A config hashtag IP route. Then we put the destination IP address. In this case, for this example, it's 10.10.10.0. Then we put the subnet mask, which is 255.255.255.0, and then we put the next hop, which is, for this example, 10.10.200.0. Okay, so where the destination is the network's destination IP address net, then the MAC address is what has been defined for the subnet for the next hop, and for the next hop, and also the IP address of the next hop and the router in question. The link between the two routers, we also have to establish that. Now let's take a look at an example. You say the command for routing the data to 10.10.10.0, you want to send to 10.10.10.0. This one we want to send to 10 from here, data packet from here. We want to route it all the way, follow here, follow this place to this place, and then send to this place. So we want to do that. This one is the destination IP address, this fast Ethernet A0/0, which is the IP address, or the subnet mask is 10.10.10.0. The destination is 10.10.10.0. This is the destination IP address or subnet mask. So that's what we enter here. 10.10.10.0. Then we follow it with subnet mask, and then so on and so forth. Now look at it. For example, if you're sending from router A, you configure it. Say router A config hashtag IP route. Then this is the destination. You enter the destination MAC address or subnet mask. This is destination IP address. Then you put the subnet mask 255.255.255.0. Then you put the next hop. How the router locates the next router. It's called the next hop. 10.10.200.2. Okay, because we are doing a gate for a third time. Okay, for the first one is .1, then .0.1, .2. Then you also have router A config hashtag IP route 10.10.10.0, which is the destination as it were. This is the subnet mask as it were. Then this is the second. You can see this is the second route, because you are using the three. Look at the second. One route is from here to here, from here to here. Another route is all the way here. All the way, this one. Meaning another route is from here, 10.10.100.0, to come here and then to come here. Okay, so this is another route. So there are two possible routes. When we are using the whole two possible routes, we can statically route our data packet to the destination. So we have to configure both if you have more of a channel through which you can route the data packet. So displaying the config router, if you want to display, just say router A hashtag show IP route. So when you type this command on the interface, router A hashtag show IP route, to display everything that you have, everything. Here the gateway of last resort is not set also. Okay, we'll talk about the gateway of last resort shortly. You can see these two, they are the two routes through which the data packet can be forwarded to the next router. Okay, to the next router. And these first ones are the interface. Okay, the interfaces. Okay, so let's move quickly. displaying the running configuration. If you want to display any running configuration, just say type on the command interface router a hashtag show run. Okay, it will display whatever is running. Okay, here are some commands and the uses, what we use them for. If you say IP route, what is it used for? If you type this command interface on a router interface, configuration interface, what do you have? It's used to specify the destination IP address, the subnet mask, and the next hop. So IP route, it shows your destination IP address, your subnet mask, and your next hop IP address. What of show IP route? When you type show to display, to show the IP route listed in your routing table. When you type the command interface show IP route, it will show you all the IP routes that are listed in the routing table, okay, between the two routers or three routers as it were. There, the next one is show IP route static. Show IP route static, meaning you always, it's the same thing. You always say it should show you the static routing protocol. So this one shows only the static IP routes listed in the routing table when you put static. But when you say show IP route, it will show you everything, both the static route, dynamic route, everything to show you. But when you are specific, you say show IP route static, to display only the static routing protocols that is available. Now you say the show running config. This one shows the router's running configurations that is available. All the running configuration, just the one we saw in the previous page just now. It will show all the running configuration. See, like this one. Show run. You see, to show you all the running configuration. All this one, like this one, to show all the running configuration that you have. Okay. So when we say show startup config, so this one, when you type this command show startup config, what it does is that it shows the router saved configuration in NVRAM. Show startup. You know, when you say startup, you're talking about your NVRAM, your RAM, your memories. So when you say show startup config, to show you all the routers saved, all the routers that are saved in your configuration in the NVRAM. What of WRM? It means this one is to copy the correct router changes to memory NIV. You copy whatever you have, the correct routers changes, you change them to the memory in your NVRAM. This is the command for it. The copy run start command. If you type copy run start command, it will display, or it will copy the correct router changes to your memory, all the correct one. It will copy them, that is be copied and sent to the NVRAM of your memory. Okay, so static route, let's summarize it, or what you call generally called static routing protocol. We say when static routes are used, the network administrator in SS become the routing protocol, because you are the one to manually enter the network administrator is the guy that will manually enter all the routing protocol into the routing table. So you are like the network administrator is like the routing protocol itself. So what this means is that the network administrator is making all the decisions regarding the data traffic routing. Okay, you make all the decisions, where it should go, where it will not go, where the data packet will go. You have to manually configure them. Okay, you are making all the decisions as the network administrator. Okay, so static route is basically what you do manually by yourself to determine which direction or which route a data packet should follow. Okay, then the static route issues, the problem, the challenges. It requires that the network administrator must know all the network data routes. This is the challenge, because you are manually doing it, so you must understand and know all the network data routes that are available to you, so that you do not congest one route and not using the other routes. The other routes will be free and one will be super busy. So you must know them so that you will not make that mistake. And then again, apart from congested one, or knowing all the routes so that you'll be able to optimize their usage, then you also have to set up the routes to each subnet and be constantly aware of any route changes. Okay, you have to be constantly aware when there are changes in the route. Now the gateway of last resort, you know, the one we say it was not configured. Now let's take a look. What is it used for? Why do we need the gateway of last resort? It's very important to configure the gateway of last resort. One of the most important applications for using a static route is for configuring the gateway of last resort on a router. We normally use the static route to configure the gateway of last resort. And how this is applied, the gateway of last resort is the IP address of the router in your network where data packets with unknown routes should be forwarded. So these are when we say the gateway of last resort, they are usually the IP address of some of the routers in your network where the data packets with unknown routes will be forwarded, because there are some data packets that sometimes we don't know the MAC address of the destination. So when we have this type of data packet, we have to forward them to this particular IP address, which is called the gateway of last resort. What it does is that the purpose of this is to configure a route for data packets that do not have a destination route. Okay, why we configure the gateway of last resort is the purpose is to configure a route for data packets that do not have a destination route configured in the routing table. They don't have a destination route configured in the routing table. So in this case, a default route can be configured. Okay, you configure a default route so that if we have any data packet that do not have the data entry from the routing table, those packets will be forwarded to the default gateway of last resort. So when that happens, the router to forward the data packets with an unknown route to another router. So this particular router will forward them to another router. Okay, the command for doing this is simply to type IP route 0.0.0.0 next hop address. You put your next hop address. Okay, it's like you keep forwarding it till it finds the computer that owns the data packet. That's what the default the gateway of last resort is used for. Okay, now here, if you want to practice, you can use the CD of this chapter. If you have the book, the ebook, and or the textbook, and open the static routing protocol challenge, and then you can configure using the configuration commands that we've described in this section. So with this, we've come to the end of this section. Thank you for joining us.